So here we begin our unit on decimals, and we need to discuss place values. So to the left of the decimals, what we've been working with, the ones place, tens, hundreds, thousands. To the right, the first place starts with the tenths, which is a TEN, but we put the THS on the end. Second place over is the hundredths, just like with money. If you have 75 cents, you have 0.75, so 75 out of 100, so 2 decimal places. Thousandths with a THS, 10 thousandths, 100 thousandths. So please take note up here of the THS's. That's the only difference, the spelling. When we read a number with a decimal in it, the decimal point is where we put the word and. So right here, we'll say that's where we spell the word and when we read the words out verbally. So 9 over 10 is read 9/10. So 10 with a THS on it. And as a decimal, it is written as 0.9. So we have just one decimal place because it's the tenths. So we have 0.9. 12 over 100 is what is read 12 100ths. So here we have hundredths, meaning 2 decimal places. So when we write 12 over 100 as a decimal, we need 2 decimal places, so it will be 0.12. So here we have 0.12 because 2 places represents hundredths. 6 over 1,000 is 6 thousandths. So here's thousandths. And again, thousandths, if you count your decimal places, and we write this out as a decimal, we have 3 decimal places: tenths, hundredths, thousandths. And we are going to backfill in the 6, which means put it off to the far end. So the 6 is in the thousandths place, and we need to fill in the placeholders of 0. So this has 3 places for thousandths. So write the word name for 0.724. We read the numbers without the decimal, so that will be 724. We don't say 724. Now we need to keep the word and for where the decimal place is. So we have 3 decimal places. The 7 is in the tenths place, hundredths, and then the 4 is in the thousandths. So this number is written out as 724 thousandths. So the 3 decimal places means thousand with the THS. So the word name for 115.03, 115, and 3 is in the hundredths place. So it's going to be and 3 hundredths. So here we have the and representing the decimal place. So 115 and 3 hundredths. So moving on to the next page, we now are going to write a decimal as a fraction. So we use the number of decimal places as our denominator, the bottom number. So we have 6, which is the whole number part, and 27, we have tenths, hundredths, thousandths. So 6 is the whole number, and then we have 27 out of 1,000. 5.09 will be 5, and then we have 2 decimal places, which is hundredths. So 5 and 9 over 100. If these fractions could be reduced, we would have to, but neither one of these can. So now we are going to reverse it. We are going to start with the fraction and write it as a decimal. 5 is our whole number part, and then 23 out of 100. So 100 means we have 2 decimal places. So here we have 5.23. So now we have the same kind of problem, but we have a denominator of 1,000. So 1,000 means, well, first of all, we have the 5 for the whole number, point. Thousandths means 3 decimal places, tenths, hundredths, thousandths. So we put the 23 towards the right end and fill it in with a 0. So here we are going to work on rounding. So we want to round to the nearest hundredths. That means we want to round to 2 decimal places. So we underline the number in the hundredths place, which is the 3. Same thing that we did with the whole numbers. We look to the number to the right. If it is 5 or bigger, the underlined number will go up. If it's 4 or less, our underlined number will stay where it is. So we are going to keep this as a 0.63. Everything after this gets dropped off. So this symbol here is a squiggly equal sign. Stands for is approximately equal to 124.63. So here we have no number, we see we have no numbers after our round off place on the decimal side. So this just means approximately. It means that this number was not exactly 0.63 and that it was rounded. So here's a number we want to round to the nearest tenth. So the 6 is in the tenths place. We are going to underline that one. And look at the number to the right, which is 9. So because the number to the right of 6 is 5 or bigger, this is going to become a 7. So we have approximately 207.7. Nothing else after our round off place, which was the tenths. Okay, so here we are rounding to the tenths again. So let's underline the digit in our tenths place, which is our first place here with the 9. So the number to the right of 9 is 8, which means our 9 has to round up. So it will become a 0, and we'll have to make the 6 be a 7. Now in this case, we do have to write the 0 because we are rounding to the tenths place. So the 0 right here actually shows that we did round to that place, and we should put the approximate symbol in front here to show that we were rounding. On this next page, we are going to review adding, subtracting, and multiplying decimals. So for adding and subtracting, this is the only time that we line up decimals. So here we have 122.5 minus 19.73. I need to get that minus sign written on there. Now to start our subtraction, we don't have a number above the 3. So it is a good idea with the decimals to write a 0 above that, and we will have to do the borrowing as usual. So here I put the 0. We have to borrow from the 5, we got the 4, and make this our 1 that we carried over. 10 minus 3 is 7. So now we have the 4 minus 7, which we can't do, so we're borrowing from the 2. Now we have 14 minus 7, which is 7. So we bring the decimal point straight down. Now we have a 1 minus 9, so we need to borrow again from the 2. Here I borrowed from the 2. Now we have an 11 here. 11 minus 2, sorry, 11 minus 9 is 2. 1 minus 1, 0, and a 1. So the next problem, 200 minus 0.63, we could just do this logically in our head. We need the remainder of the 63 cents to bring us up to $1. So it would be 37 cents. So you should get 199.37. Okay, so this is the answer, just doing it logically. But I am going to show the work as I always do. So we will have 200 minus 0.63. Now we need to line up the decimal. The number 200, if we're going to put a decimal on it, it always is at the very end of a whole number. So we're going to do 200.00. So we have some numbers above the 0.63. So here we got the 200.00 minus 0.63. So we have to start borrowing right away. We have to come all the way over to the 2, borrow and make that be a 1. And we'll make this be a 10, but then we have to borrow from the 10 to make a 9. So these are all going to become 9s before this initial 0 will become a 10. So here we borrowed, we got the 1, would have been a 10, became a 9, 10 that became a 9, 10 that became a 9. Now we have our 10 finally, so 10 minus 3 is the 7, 9 minus 6 is the 3. So there's our answer by showing the work. So moving on to multiplying decimals. This is where we do not line up the decimals. You can, it is just not necessary, and it makes it much longer than it needs to be. So here we have 6.2, 1.58. We do not need to line those up when we write our problem out. So right here, it's fine to ignore the decimals while you multiply. Rewrite the problem without them. At the end, if you remember, we count the total number of decimal places in both factors, and our answer needs to have that number of places. So here's our first multiplication by the 2. 8 times 2 is 16, so carrying the 1 up here. 2 times 5 is 10, plus 1 is 11, and then we carry a 1, so 2 times 1 is 2, plus 1 is 3. Now here's where some people are having trouble still. We are ready to multiply by the 6, but it's really a 60. It's in the tens place. So when you go 6 times 8 is 48. The 8 comes down right here in the tens place, not right here. So we traditionally put a 0 here as a placeholder so that we shift over when we do the 48 that we need to work with. So 6 times 8 is 48. We are putting a 4 up here and bringing our 8 down. 6 times 5 is 30, plus the 4 is 34, so the 4 is here. We'd be putting a 3 up here. 6 times 1 is 6, plus the 3 is 9. So we add as usual. So now we look to our original numbers. We had 1 decimal place here and 2 decimal places there. So we need 3 total decimal places in our answer. All right, so we need 3 decimal places. So you start at the right end of your number, because it makes it be a whole number right now, and we count back. 1, 2, 3. So we're going to put the decimal between the 9 and the 7. So here's our answer, 9.796. If you insist on having the decimals in the problem up here while you initially do it, this number had 3 digits in it, so we would normally write that on top and the fewer digits underneath, just like usual. But when you come over and write it with the decimals in it, we're going to still line it up exactly like this. So right here, we still justify the numbers just like you always do in multiplication. Do not shift this over and put 6.2 underneath here and then put a 0 on there. It makes you just have all of these same numbers, but you'll have an entire row of zeros when you multiply by the 0. You're still going to have to move your decimal over 1, 2, 3 places in your final answer. So here we're going to do these 2 here. So looking at this problem, we have 2 decimal places in each part. So in our final answer, you're going to need 4 decimal places. So ignore the decimals as you multiply. This is the same as doing 17 times 3, getting that answer, and then shifting the decimal. So here we have the 17 times 3 is 51. But we need 4 decimal places, 2 in each number. So we start on the right end of our number and come back 4 places. 1, 2. We're going to need 2 zeros on here to come 2 more places. So 0.0051 is our answer. Now I want to explain why you do this. Hopefully you remember that you used to do this, but why? If we take the original 0.17 times 0.03 and write them as fractions, they are both have 2 decimal places, so that is out of 100. So we have 17 over 100 times 3 over 100. And we have learned when you multiply fractions, you go straight across. So 17 times 3 is 51. 100 times 100 is a 1 with 4 zeros, which is 10,000. So 51 over 10,000. And now we are going to write this as a decimal. So we have 10 thousandths. So if we count our places, we have tenths, hundredths, thousandths, 10 thousandths. We will need 4 decimal places. So tenths, hundredths, 1,000ths, 10 thousandths. So we are going to fill the 51 in at the end and put the 2 zeros right here. So this shows why you need the 4 decimal places, because you have hundredths times hundredths, which is 10 thousandths, which is the 4 decimal places. So now we're going to multiply by multiplying decimals by powers of 10. So here we're multiplying by 10,000. So in the past, when we multiplied with the zeros, I talked about offsetting the zeros. So let's look at this as 8.554 times 10,000, offset all those zeros. So we're multiplying by 1, 8554, with 4 zeros attached. The original had 3 decimal places in it. So we need to come over here and count back 3 places. 1, 2, 3. So right there is where our decimal needs to go. So there's the decimal. So this is our answer, 85,540. So now let's take a look at this as an exponent problem. 10,000 would be 10 to the 4th power. So here I just rewrote the original problem, 8.554. But 10,000 is 10 to the 4th, because 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 would be 10,000. So let's take a look at the problem in this format. If we start with the 8.554, look at what our final answer was. Our decimal was originally right here. It ended up over here at the end. 1, 2, 3, 4 places to the right. So when we multiply by a power of 10 like this, which had 4 zeros in the original problem, you just basically take your decimal and move it over to the right 4 places. 1, 2, 3, and we would have to put a 0 on there to get a 4th place, which would give us this whole number. So here's where I showed that. Move this decimal 1, 2, 3, 4 places and get the 85,540. This notation here is called scientific notation. When you move up to the next class and when you take chemistry, you will use this quite a bit. So the point of this multiplying by powers of 10 is to realize we do not need to actually multiply it by 1,000 and offset the zeros. We want to write this as an exponent. So 1,000 would be 10 to the 3rd power. So we're starting with 1.25 and moving our decimal 3 places right. 1, 2, 3, so we need to put the 0 in there. So we end up getting a whole number, 1,250. Right. So now 0.16 times 10, we don't really need a power here. We are just going to move our decimal one place to the right because we only have the 1 0. All right, so 0.16, move it one place to the right, 1.6. And that normally happens with multiplying whole numbers. If we have to do 23 times 10, we basically take the decimal after the 3 and move it over one place and put the 0. So it's the same idea. So on to the next page. We're going to look at taking a fraction, 21 over 5, and writing it as a decimal. So what you need to recall here is that if you have a fraction, a over b, it means division. So the top number goes on the inside and the bottom number is on the outside. So to write this as a decimal, we are going to do division with 21 on the inside divided by 5 on the outside. So here, now we're going to divide like usual, 21 divided by 5. The closest we can do is 4. So 4 times 5 is 20, subtract, and we have a 1. Now, up until now, when we got our remainder down here, we would just write remainder 1, or with the fractions, we would write 1 over 5, so 1/5 would have been a fraction. Now that we are moving into decimals, this is where we are going to continue dividing. So we're going to put a 0.0 on here, and then divide again. So here's 0.0. So we have our 1, we're going to bring the 0 down, and then do 10 divided by 5 is 2. So 10 divided by 5 is 2. We get a 10, 0 remainder. So now the difference is we have a decimal on the inside number. All you're going to do is bring it straight up. So our answer will be 4.2. Alright, so 1 divided by 6. We want to write this as a decimal. So this is less than a whole. When we do this, we're going to get point something. This one, the top, this was an improper fraction because the top is bigger than the bottom. When you divide that, you're going to get a whole number part. So you need to remember on this to just do the division in the correct order. The top number goes on the inside. So we have 1 on the inside, 6 on the outside. So right out of the gate here, we can't even do a division at all. So we're going to put a decimal point here and a 0. And we're going to do 2 zeros at least to get started. So 1 is the same exact number as 1.00. You may need to extend your line up here now. So now we are going to do the 10 divided by 6, which the best we can do is 1. And in the process, we're going to bring our decimal straight up. Okay, so 10 divided by 6 is 1. 1 times 6 is 6. Subtract, and we have 4. Now, we're going to bring that next 0 down. 40 divided by 6, the closest we can get for that is 6. So the 40 divided by 6 is 6. Times 6 is 36. Subtract, and we get 4 again as our remainder. So we're going to add on another 0 and divide one more time. So here we had the 4. I put another 0 on, so 40 divided by 6 is 6 again. So we get 36, subtract, we got 4. So you can see you're going to get a 6 every time up top, and you're going to continue getting the 4. So this 6 repeats. This is the way we write a decimal answer when we get repeating numbers. 0.16, and we put the bar over just the 6. That indicates that number keeps continuing. We do not put the bar over the 1. So normally I would leave this problem 9 over 11 for practice in class, and we'll do the same. So if you want to look at this now, go ahead, but we will review this in class. This next group of problems will be on the very back page of your packet. They may already be typed up on there, but if not, just write them down. So 2.13x minus 5.08x. This problem would just say simplify. So we're looking to combine like terms. Now, let's say this was just 2x minus 5x. We would get 2 minus 5, which is negative 3x. So we're taking a smaller decimal away from a bigger decimal. The signs are different, so we are subtracting. Since we can't use a calculator, we would be writing 5.08 minus 2.13 and get our answer. But when we get the answer, we need to make it be negative. So here 5.08 minus 2.13. This is where we line up decimals. 8 minus 3 is 5. We have a 0, so we're borrowing. We got 4. This becomes 10. Minus 1 is 9. 4 minus 2 is 2. So when we get our actual answer, we got to remember it was 2 minus the 5. So it's negative 2.95x. So here's our answer, simplified. So here's the second problem, a minus 0.25a. Now this 0 right here doesn't really affect our answer. And the reason they put that there is so that it clearly shows where the decimal is and you don't lose track of that. But you could just forget this and write this as 0.25a. So we're looking to simplify this. If we had a number right here, like 5, we'd do 5 minus 0.25. You need to remember that if there's no number in front, that there's a 1 there. So here I've written the 1 in front and minus. I did drop the 0, so 0.25a. So we're basically doing 1 minus 0.25. Well, that's 1, basically $1, minus 25 cents. So it's 75 cents left over, which is 0.75a. So here we are going to solve for x, which means we now have an equation because we're being asked to solve. 6 minus 1.2x minus 3.9x equals 16.2. So over here on the left side we have like terms, the negative 1.2x and the negative 3.9x. Because they are both negatives, we actually have to add their coefficients, which are the front numbers. So we actually need to do 1.2 plus 3.9 and realize that our answer is negative. So over here we have negative 1.2 and a negative 3.9, so we're actually adding 9, 10, 11, carry the 1, 3, 4, 5, so negative 5.1. So these two terms here combine to negative 5.1x. So the 6 comes straight down, minus 5.1x equals 16.2. So now our like terms are the 6 and the 16.2. We need to take this and subtract it. So minus 6, minus 6. So minus 6, minus 6. Over here, you'd want to make sure that you know how to line the 6 up. A 6 with a decimal would be 6.0. So the 6 is going underneath this one. So we end up with negative 5.1x equals 10.2. So our last step is to divide both sides by negative 5.1. So dividing both sides by negative 5.1. So now we have a positive divided by a negative, which we know will be negative. We haven't done the division of decimal stuff yet, but this one is pretty basic. The 10 divided by 5 is 2. But if you take 5.1 and double that, it would be 10.2. So this top is twice the bottom. So x equals negative 2.